Today we're going to learn about normal distribution and a rule that applies to that called the empirical rule. So normal distribution is just when data is shaped like a bell curve, like what we see here on our screen. We would say our data, whether that's class averages or heights of students in the class, is normally distributed if it's in this shape. And there's something pretty special about this shape of data in that the empirical rule is going to always apply. It's going to help us analyze the data. So the empirical rule tells us that 68% of the data is always within one standard deviation of the mean. So the mean, we're going to use this symbol. That means the mean or the average is the middle of our bell curve. And standard deviation, which is this symbol, is simply, the average distance from the mean. So each data point's distance from the mean. So if we have something that's one standard deviation, either one higher or one lower, about 68% of all data is going to fall in that range. Now, if something is within two standard deviations, about 95% of all data is going to fall in that range. So either two standard deviations higher or two lower. So we'll summarize that real quick. Plus or minus just one standard deviation will be about 68% of all of your data. Plus or minus two standard deviations is going to be about 95% of all of your data. And then plus or minus three standard deviations should contain about 99.7% of all of your data. So let's see this rule in action. For males in a certain town, the systolic blood pressure is normally distributed with a mean of 120. I'm going to write that down, with a mean of 120 and a standard deviation of 10. A standard deviation of 10. Using the empirical rule, determine the interval of systolic blood pressures that represent the middle 99.7% of males. So here's what I'm looking for is, hey, what is the blood pressure range that 99.7% of all males fall into? So I know here's the average. Okay, here's 120. And to capture the middle 99.7%, I have to go to the right 3 standard deviations, and I need to go to the left. I need to subtract 3 standard deviations. So here's what that's going to look like. We've got 120 in the middle. To get to the upper end of our interval, we're going to add 1, 2, 3 standard deviations. So I'm adding 10 3 times. I see the upper end of my interval is 150. And to get to the lower end, I need to subtract 10 3 times. And I see my lower end of the interval is 90. So 99.7% of males in this town should have a blood pressure between 90 and 150. So if you come into the doctor's office and you rank below that or above that, we know you're an anomaly. Maybe we need to check you out. Let's see it in action in another way. When Zakira runs the 400-meter dash, her finishing times are normally distributed with a mean of 84 seconds. Let me just write that down. a standard deviation of 1.5 seconds. So my average distance from the mean is at 1.5. Using the empirical rule, what percent of races will her finishing time be between 81 and 87 seconds? So here we know that on the low end, she takes 81 seconds to finish a race. And on the high end, she'll take 87 seconds. Her average is 84. I need to figure out what percent of her races fall between 81 and 87 seconds. So let's figure out how many standard deviations that is. Well, if I add 1.5 once, it looks like I'm sitting at 85.5. If I add it again, I get 87. So it looks like on this side, we added our standard deviation twice. Let's double check on the other side. If I subtract my standard deviation, looks like I'm at 82.5. And if I subtract it again, I'm at 81. So sweet, over here, I was also 2 standard deviations apart. So if you remember our rule, here's the middle. And here's me going 1, 2 standard deviations, 1, 2 standard deviations. It looks like 95% of her races will finish between 81 and 87 seconds.